Recording. Here we go. Okay, so again, good morning everyone. This is APNIC e-learning web class. Today's discussion is all about DNS concepts. Okay, so this is the first of our 3 sessions for today. We do e-learning sessions every Wednesday, and actually when we concentrate on a particular topic, it comes in as a series. So this one is DNS concepts. It's part of a 3 series session. So the second one of these is reverse DNS delegation. We will have that I think it's a third session for today. And then we also have another one, which is DNS security. So hopefully by the end of this class, if you have enough knowledge about DNS and an overview of that, then hopefully you will also attend the next 2 sessions. So just a bit of some administrative stuff. First of all, today is the 16th of January in 2013. It's 10:30 in the morning in Brisbane from where I am broadcasting this session. Well, it's still a bit early for some of you who are here as well. So I'll just introduce myself first. My name is Cheryl Hermoso. I'm a training officer with APNIC. I've worked with them for the past 1.5 years. And I work as a training officer. So as a training officer, we go to different economies, deliver the different internet technology messages, and these are our specialties: network security, IPv6, DNS and DNSSEC, and also internet resource management. So basically everything that has to do with internet technologies that will affect the APNIC internet community. Now, if you have any questions throughout this class, the way to reach me is either using the chat, and maybe after this, if you still have questions that's brimming on your mind that you haven't asked during the session, then you can also send me an email at my email address that you can see in the slides. Now, if there are any issues all throughout the session, please call my attention. You can also check out the link that is on the slide. However, I think it is better and it's faster if you will just call my attention using the chat. So if for some reason I become choppy or my audio you can't hear my voice, then please tell me outright using the chat. Now this class will run for 1 hour, so we will allot about 45 to 50 minutes in the lesson proper. The rest is all the administrative and sound checks, and also if you have any further questions towards the end. Just a reminder as well that there will be a brief survey. Now that survey is just very brief towards the end, around 11 items, which will also tell us whether you've learned something from the class or whether we have achieved our goal for you in attending this particular class. If you have any other suggestions as well, such as new topics that you want to be discussed, then that is also the venue where you can do that. Okay, so with that, I think enough of the introduction that took a bit long. We'll just move on ahead and start with our topic, which is DNS. So we will have a look at the concepts or the basic fundamental aspects of domain name system. It's not meant to be a discussion of any specific configuration or any practical hands-on queries, such as how do you implement DNS using a particular software. No, we're not going to do that. In this class, we will tackle what is DNS, what are its features, what are the basic concepts, terminologies, the fundamental aspects, and the components that are necessary for understanding how it functions. Okay, so that's what we're going to look at in this class. So first and foremost, we'll begin with a definition of what is a DNS. What's a DNS? I'm sure you've heard about it before. You've used DNS in your daily activities. You have configured a DNS setting on your local machines, or if not, you have asked maybe some other your technical support to do that for you. So DNS basically is a mechanism for translating one object to another object. Okay, so more specifically, when we say DNS, it's a means of a mapping. It maps one resource, so we call it resources, one resource to another resource. What are these resources? It can be a name, it can be a number, it can be a text. But most, at its basic level, when we say mapping of DNS, we usually map a name to a number or a number to a name. So IP addresses, that's the number, that's V4 and V6. Name is the domain names, okay, the names that is assigned to a specific machine. Now, the main driving force for having DNS at its early stages in the internet is very simple. It's just easier to remember names rather than numbers. Let's take, for example, the mailing address. Say, if I tell you my name, and if also I tell you my contact number or my mailing address, which is easier to keep in mind? Okay, in the same way, if I tell you my host name and if I tell you my IP address, which one will you retain faster in your mind? So DNS is like that. DNS is a way of mapping these two data or these two resources. It's a lookup mechanism. So you have this list of all these mappings. It started out as just a file, a text file. So you have like, let's say, if you have one certain mapping, you just add it on to one list. It is maintained before by a guy. His name is John Postel. Now these mappings are then, for quite some time, it was like that. But after a while, it just grew bigger and bigger. And it's because it's centralized, it takes a longer time to access the file. And if you need to add something on that file, how do you distribute them to all others that are hosting the same file? Now that becomes a problem. So basically, that's how DNS grew to be. Before an application can send an IP packet, the IP address of the destination host must be determined, right? But with DNS, we only need to remember the names. Now, this name will map us to the actual destination address. That's why DNS was devised, to obtain the IP address for a given domain name. When we say, there's another thing, like if you do it the reverse way, the inverse process, this produces the domain names given the IP address. This is called a reverse address mapping. Okay, so that's the reason we have DNS right now. It's because we need some form of mapping for the names and the numbers, which will make it easier for everyone, okay? Especially at that time, in the early 1990s, the internet is growing, okay? So it's just an easier way to access the machines that are connected to the internet at that time. Now, there are three components. Now, remember this because this is very important. There are three components. We will discuss each of them as we move on with the slides. Now, these three components are very important in the proper functioning of the DNS. Okay, these are the necessary parts of the DNS. One is, of course, what we call a namespace. When we say namespace, it's a database. It's like just a space that contains all the information. So there are many namespaces that are distributed around. When we talk about namespace, we will also refer to terminologies such as delegation, zones, and domains. So we will have a look at those terminologies on a later slide. The next one is servers. So when we have a namespace, who do we use to make this namespace available to the clients? So that is the role of the servers. They make the namespace available to the clients. They serve a particular domain, okay, or a particular zone, and then give answers to anyone who is querying for that information. The third component that we will look into are the resolvers. Now, resolvers, you can say that they're also the clients. All of your machines, all your computers, your operating systems have built-in resolvers. These are the hosts that will make the query to the servers about a particular namespace. Okay, so let me repeat that. So this ties up all three of these components. A resolver will query the servers about a particular namespace and find out the particular information on that namespace. Okay, so those are the three components. Again, we will have a closer look on each one as we move on with this lesson. As I've said here, domain name system is a critical piece of the internet infrastructure. It's a critical infrastructure. mainly because everyone, all of us, if I ask you right now, do you know what is the IP address for a specific domain name? Let's just say your own domain names. Do you know the IP address corresponding to that? In normal cases, all of you might answer, no, you don't. That's because we rely heavily on the DNS to make these domain names, to make these websites, or to make the email servers accessible. That's using the DNS. What else have we missed there? A DNS is also a globally distributed, loosely coherent, scalable, reliable, and dynamic database. I think I also have that on another slide. So that is the main feature of a DNS system. It's globally distributed, meaning that it is not stored in only one location. It is globally distributed. If you have your own domain name, then you can set up your own DNS server. Okay, that is also good because with this global distribution, we have loose coherency as well. Like all of these servers rely on each other. They are independent at the same time they are coherent. The data or the information that is saved on one server will eventually be forwarded and will be stored on another server. Okay, they will query each other. There is a communication in between them, so that the information that they are providing will be consistent. It is also scalable. You can easily just add DNS servers without affecting the entire DNS itself. Okay, the DNS system is like a tree hierarchy. Okay, it starts up as a root, going down to the top level domains, going down to several levels of subdomains. Now, if you add just one branch to that DNS tree, it will not affect the function of the entire tree. Okay, there will be no delays, there will be no downtimes, which is good. It is scalable. Compare that with the old system. Before DNS, we are just using hosts.txt. Now this is still being used. If you look at some of the Unix or Linux machine, they have a file called hosts.txt. Now, before querying the DNS, you would usually query the hosts.txt file first, okay, if there is any mapping there. Now, before we had DNS, the system is like that. So that will just grow bigger and bigger. That is not scalable. Okay, because once you add new domains, new mappings to the system, it will have to be added on just that one file. Okay, and when it grows bigger, and if something goes wrong, it gets corrupted, or the machine that's holding it crashes or something like that, then how will everyone else have access? Okay, the point of failure is on just one system. Now with DNS, it's not like that. Okay, it's scalable. Okay, it's globally distributed, meaning you don't have just one point of failure. It is distributed worldwide. Lastly, it's reliable and it's dynamic. Now, when I say dynamic here, that means that you can easily modify, you can easily add your mappings without stopping the service at first, okay, and then starting it after you made the changes. No, you can actually do that while your system is up and running. Okay, so that's what we mean by dynamicity. Okay, so these are those features. Next, we'll have a look at the tree hierarchy. When I say a DNS tree, as I've mentioned, it is scalable. That's because it follows a tree hierarchy. Now here, you can see that it starts up as from the root. From the root, it branches out into several top-level domains. The top-level domains, or TLDs, okay, there are around 300 of these TLDs that are operating around the world. Now, when we say top-level domain, it can be subdivided into a few other things. We have generic top-level domains, things like .gov, .com, .net, .org. Those are generic top-level domains. We also have country code top-level domains, or CCTLDs. Now, this refers to different countries or different territories. Usually, it is expressed with two letters. So when we say that AU, that means Australia. When we say .sg, that means Singapore. Okay, when we say that, what else? That CN, I think it's China. Okay, FJ is dot Fiji. So those are CCTLDs. They are awarded to different like bodies that is within one territory or one country itself. Okay. Another type of top-level domain is what we call the internationalized domain names. Now, these are fairly recent. I think it was, if I remember correctly, it was around 2010 when it was finalized. Now, this one refers to top-level domains that are in a different language. I mean, different script. It's not using the alphabet or Greek that's used in Greek, Hebrew. It uses native scripts, okay, such as Arabic, Chinese. So those are IDNs. Now, there are also infrastructure TLDs. As you can see here, if in the future you attend a, let's say, the reverse DNS class, then you will notice more about this particular one, .arpa. This is the infrastructure TLD. It's everything that has to do with IP addresses falls under this. Everything that has to do with reverse DNS. It's also used for technical infrastructure purposes that is managed by ICANN under the, I think, the Internet Architecture Board. Okay, so let's move on and describe about the fully qualified domain name. Now, when you write a domain name, let's just say, for example, you want to access www.apnic.net. Okay, so when you write it down, you start up from the bottom of the tree going up. So if you look at this tree, let's try to traverse it. You want to access a website called www.apnic.net. So where is that? It's here, www.apnic.net. So when we say fully qualified domain name, it refers to the entire, okay, to the entire path where you traverse up to the root. So actually, when you write it down onto a DNS zone file, it will be like this, www.apnic.net. Okay, make sure that there is a trailing dot at the end. So that is the fully qualified domain name. That is how we represent a domain name using the DNS hierarchy tree. Now, how do we administrate these domains? Different entities can be responsible for parts of a name server. Okay, I think you know that by now. Let's say .NET. There is one organization that is in charge of the entire .NET zone or the entire .NET domain. Okay, however, they can delegate. Okay, remember the term delegation. They can delegate a branch of the tree to someone else. So the administration will be left to someone else and they will only administrate the parent zone, which is .NET. So that's how the DNS works. That's how we can say that it is globally distributed because someone else, one other organization, will be in charge of a particular subdomain. Now let's take a closer look at that here. So when we say domains, domain is a very common terminology that we use in DNS. Domain is simply another namespace. There can be many namespaces and several parts who can maintain their own domain. Example is, let's just say .NET here. So when we say .NET domain, it refers to the entire branch, okay, going down from this top level domain and all the branches that is underneath that. Okay, so I think I have an animation here. Yeah, there you go. When you say .NET domain, it refers to the entire branch, to the entire thing that falls under the .NET branch. Okay, so when we say .org here, it probably refers to this entire thing here. When we say .au, it will refer to everyone that is underneath the .au branch. Okay, that is a domain. It's simple, it is straightforward. Now, just to make things a bit more complicated, how about the apnic.net domain? So again, it's the same thing. It refers to everything that falls under that particular branch. So everything here, so apnic.net, as you can see, is a subgroup of the .net domain. So both of them are domains. However, when you say apnic.net domain, it doesn't include the parent branch, which is the .net. Okay, so I hope that is clear. Now, just to steer things up a bit, let's discuss about delegation. What is delegation? Delegation is when one entity passes part of their responsibility to another entity. That is delegation. It's not a word that's only used in DNS, it's a generic word. So when we say passing of a responsibility to another entity, that is already delegation. When we try to fit that in onto the DNS, when we say delegation, a parent zone, in our case earlier, .NET zone, he can delegate its subdomain. Okay, in the example, we're using apnic.net. So he is delegating the subdomain apnic.net to the administrator of the apnic namespace. This can also be seen as a parent-child relationship. .NET is the parent. He delegates some part of his space to apnic.net. In the same way, apnic can delegate its subdomain. This time around, apnic.net becomes the parent and he has a subdomain. Now, as I've said, when we traverse the DNS, when we try to find out the IP address for a specific subdomain, we traverse it using the tree, correct? Now, how do we know? How do we find out if we have, let's say, if we have delegated some parts, how do we still access the tree? The answer there is using what we call a glue record. The parent must still remember to whom it delegated a subdomain. That is what we use there is called a glue record. So the parent zone, the parent domain still remains contact with all of its subdomains. All right, so I hope that's clear. Everyone, any questions with this? So far we've discussed about domains and delegations. Now, just to add more to that, let's discuss about zones. Now, what is the difference between zones and domains? Zone is an administrative space. Okay, this information is relevant to the administration of just one space. Earlier, we've discussed about domains. Okay, so part of the net zone has been delegated so that anything that is under apnic.net has now become the responsibility of apnic to maintain it. Okay, so that is what we call a zone. When it is within your responsibility to maintain a specific part or a specific branch of the DNS hierarchy tree, then that becomes your zone. Their responsibility is to make sure that the delegation is given properly and understood properly. Now again, there is a link between the .NET and the apnic.net. Okay, that is important. In DNS, delegation is highlighted using a glue record. This is the link from your parent to your child. The parent has to know how to get to the child. Now we can actually define a number of zones in a certain hierarchy. So that's really the first of those three parts. Now have a look. I think I have, here I have a diagram showing what is a zone. Here you will see the difference between zone and domain. Remember, we have the .NET domain, and I told you when we say net domain, that refers to everything that falls under a specific branch. In this case, anything that falls under the .NET, okay, top level domain here. Now, when we talk about zones, okay, now this is still another domain, which is apnic.net domain. When we talk about zone, say, where here is the .NET zone? We have already delegated its sub-branch. In this case, just to make things simple, we thought of making apnic.net our only branch for .NET. Okay, that leaves us with only the .NET zone. because we've already delegated this domain. That means that no longer falls under our own administration. So our zone is only .NET zone. Okay, is that clear? In the same way, when we have apnic.net zone, in this example, let's just say that training.apnic.net has been delegated to another admin. Now that means that I'm only in charge of this particular part of my domain. So that is my apnic.net zone. Okay, it didn't include training.apnic.net because it has already been delegated to another admin. Okay, so I hope you can like follow the terminologies and you can connect them together. Zones, domains, delegations, blue records. So those are very important terminologies that we use when we describe everything about a namespace. Okay, so any questions? So far, we've described the first of the three components, right? Which is a namespace. Now we will move on and discuss about the name servers. Okay, that is the second component. Now, what is a name server? Name server basically is just, they're the ones, they are hardware or software, and they answer the DNS queries. There are various types of name servers. We can have an authoritative name server. When we say authoritative, from the word itself, it means that they are the ones who are responsible to give reliable answer for a certain zone. If I ask what is the IP address for the web server at apnic.net, the authoritative server is the one that is authorized to give answer for that. Okay? Everyone will eventually query the authoritative server to give the final answer. Okay? When you say authoritative, we can also have two types. We can have a primary and a secondary server. Now, both of them are the same thing. Both of them answers the same queries. Okay? The thing here is that the reason we have primary and secondary is mainly for redundancy. As I've told you earlier, the DNS is a critical infrastructure. So you can't rely on just one machine, just one DNS server to serve for all your domains. That is why we should have at least one primary server and several secondary servers. Normally, we would recommend 2 secondary name servers. Now, how do we make sure that they all have the same information? The thing there is you have your primary server, all changes will be done on the primary server, and it will be propagated to the secondary servers. Okay, as you will see later on, the secondary servers actually queries the primary server at specific times. Okay, so let's say every 4 hours, the secondary server will query the primary server, okay, to see whether the information that from the primary and the secondaries are still the same, are still consistent. Okay, another type of DNS server is what we call a recursive server or a caching server. Okay, now these are two different types of servers. However, most recursive servers are also caching, and most caching are also recursive servers. So that's why we usually just fuse them together and call it either a caching server or a recursive server. Okay, but primarily when we say recursive server, that is what we configure in our machines. Let's say I set up my IP address, my DNS on my laptop here. I will specify 2 DNS servers. That is a primary and a secondary. Okay, it can be our authoritative server, but it doesn't necessarily have to be that. Okay, it just has to be a recursive server. Okay, that means that when I try to query for a specific domain, my machine, my operating system here, will go to the IP address that is specified in my DNS, okay? And then that will act as the recursive server. It will act in my behalf and query everyone from the outside, the DNS infrastructure basically, to get the answer, okay? So just to tie that up, we use the recursive server, okay, to act in our behalf to do all the queries. Okay, that is a recursive server. As I've mentioned, it can also be a caching server. Let's say, for example, I tried to go to google.com, okay, and then there's another machine in our local area network that does the same thing. He wants to query for the IP address of google.com. Now we have the same query. I made the query first, okay, and then after a while he did his query. Now my recursive server doesn't have to go out to the internet and ask for the same question again. From the name itself, caching, it saves the file, it saves the answer to the question to the cache for a specific period of time, so that any other request that comes in the future will just have to go through the recursive server, and he already has the answer for us. Okay, most of the servers are also functioning as a mixture. They can be a recursive server, they can be an authoritative server at the same time. Okay, I think I have one question from the chat. Can I have the training recorded sessions later? I'll give you more information about that towards the end, right? So we'll just, for now, I'll try and answer if you have questions that is related to what we're talking about rather than the materials. I'll talk about the materials towards the end. I hope that's all right with you. Okay, so let's move. What else do I need to say about this? So those are the name servers. Now, how do we actually query the DNS? I think that is the basic function that you all need to know. For some of you who don't know that yet, this is the diagram that shows you how the DNS basically functions. So first off, I have a machine. I want to go to a specific domain. So in this case, let's try to go to www.example.edu.au. Now, since I want to go to that website, I need to know the IP address, right? Okay, it's not good if I only know the name. I need to know the IP address of the server that is serving that website. Okay, so I need to know the IP address. What I'm going to do is, now this is the DNS hierarchy. You have top level domains, you have CCTLDs, you have different types of servers. Now I have here a local DNS. When you say local DNS, this is the one that I set up on my machine. Okay, this is one that I will query. This is actually a recursive server. Okay, I hope you remember that from the previous slide. This is a recursive server. It will do all the recursion, all the query for me. Okay, so there I will ask my local DNS. My local DNS will go straight to the root server. Okay, how do I know to go to the root server? How do I know where is the root? That is configured on this machine itself. It has a file called the hints file. Okay, this hints file contains all the IP address for all the root servers. That's how I will know where to go first. So first and foremost, where do I go? Root. We'll start up from the top level of our DNS hierarchy tree. Now from there, the root will refer us to the next level domain. Okay, why is that? Because the root doesn't have the answer for our question. I ask him, what is the IP address for this? The root will tell you, sorry, I don't know the answer, but maybe you can ask .au. Okay, the IP address of .au is a.b.c.d. So then I will go to .au. Now, how does the root know to go to .au? Remember glue record? That is how the top level or the higher level DNS will have a glue record of the lower level subdomain or server who holds or who may have the answer that we're looking for. Okay, so we go to .au. .au doesn't know the answer, of course, so he will refer us to .edu.au. He will tell me, hey, this is the IP address of .edu.au. Go there and he might know the answer to your question. Okay, so again, .edu.au doesn't know the answer, so it will refer me to the next level down, which is .example.edu.au. Now, this is our authoritative server for the domain example.edu.au. Okay, let me repeat that. This is an authoritative name server. It serves all that falls under the domain example.edu.au. Right? So of course he knows the answer to my question. He will give me the IP address. Now he will say that this is the IP address that you're looking for. Now, since I know the IP address, I can go straight away to www.example.edu.au, which is a web server. Alright? Now this local DNS, if he is also a caching server, then he will retain a copy, okay, of the answer for a particular amount of time, which is called the TTL, okay, the time to live. Okay, so this is just another diagram. It basically shows the same thing. I think what I wanted to show you here is how easy it is to act both as a recursive server and a caching server. So since it is a caching server, after it has given the answer to my resolver or to my machine, then it will save a copy to its own cache. Any questions for this? Now let's have a look at resource records. Now since we're talking about name servers, now name servers have files, okay, which contains all these mappings. It can be a text file, okay, it can be something that is readable only by the software that implemented it, but in most cases you can actually go through a zone file. We call it a zone file. That is where we store information about all the mappings for a particular zone. Okay? Now, inside the zones, we have many records. We call it resource records. They are the actual entries in a DNS zone file. Now, when we say a resource record, there's a structure on how to write a resource record. Now, these are the components. You need to have a label, okay? That is the name that you will substitute for your fully qualified domain name. That is your subdomain. Let's say www.example.com. That can be a label. Now you also have a time to live. Now this is the timing parameter that sets the expiration time or the expiration limit for that particular resource record. So once I query for a particular record, okay, I can only store it up to a maximum amount of time, which is specified by the TTL. Next is the class type. We have different types of classes. However, we only usually just use IN. IN stands for internet because all our queries has got to do with the internet. So the class type that we actually use is IN. There are other ones that such as .ch for chaos, but I think for now it is important to just ignore this altogether and just think that when you say a class, it will refer to IN, which stands for internet. Okay. Next one of the components of a resource record is the type. Now this one is very important. I encourage you to have a look at the different types of a resource record. Now we have we have a record, we have quad A record. I think I have that on the next slide. We'll go into more detail on that in the next slide. But from here, these are just different resource record types that is used for different purposes. Now, if you want a mapping for IPv4 address, you will use a different type of resource record. Okay? If you want a mapping for IPv6, that's also a different type. If you want a mapping for the mail exchange or the mail servers for a particular domain, that's a different type. If you want a reverse mapping, IP address to domain names, then that is a pointer record. Okay, so we'll have a look at that in the next slide. The last one is RData. RData is everything, all the additional information that comes after the type identifier. So it can be short, it can be very long, because you can have a text type. So if you have a text type, you can put in a lot of information in the RData part. Okay, So let's have a look at some of the resource record types. So when you say types, it's this one. Okay, now these are the common resource record types that we use. A is for address record. So if you have something like this on your zone file, this is the mapping for an A record. So www.apnic.net, in for type internet, A for an A record, and then the R data will contain the IP address. Now, if it is a mapping of an IPv6 record, we use quad A. Okay, we pronounce this as quad A. Now, after that, your R data, of course, must contain the IPv6 address for the domain name www.apnic.net. Okay, another one that is very important is the NS record. Now, this is the name server record. This will tell you which name servers are authoritative for a particular zone or a particular domain name. Okay, another one is a pointer record, which is the inverse. So here, as you can see, it's the inverse of the A record. So if you have the IP address mapped onto a domain name, then you are using a pointer record. Okay, next one is CNAME. From its name itself, it is a canonical name. It's an alias. So let's say you have one particular server. Now that server acts both as a web server, okay, a mail server, maybe even a DNS server, an FTP server. So it has many functions. You can have many aliases for that server, all of which are referring to one particular, okay, machine. So you can use a CNAME record for that. All right. Next is a mail exchanger or MX record. Now this one is for the mail servers. Okay. So if I have an email, okay, going to, let's say, Cheryl@apnic.net, now they will go to these two mail servers. Okay. So we use a type MX. Now this one, 10 and 20, tells you which has more priority. The lower value means it has more priority. So all mails will first check with mail01.apnic.net. Okay, if it doesn't respond, or if I can't send it to that mail to that mail server, then it will go to the next one, which is mail02. Okay, then it will just round robin between the two. Okay, so those are some of the common resource record types. There are still plenty of others. Okay, if you want the full record, go and have a look at the RFC for DNS. But for most cases, if you're a beginner, these are the only things that you need to know about. So that's it. Any questions? No questions from everyone? I hope you're still listening. I hope you can still catch up. If there are words that seems like, say, you can't understand, please let me know and I'll I'll explain it further. Now, coming from the previous one, we just described the different types of resource record types. We described the, let's say, the syntax on how you will write a resource record in a zone file. Now, this is what goes on in one zone file. This is an example zone file for the domain apnic.net. Okay, the domain is specified here, apnic.net. Now, one resource record. Let's just say this one. This is the first part is your label. You have your TTL, which is 3600. This is usually the default. The class is in for internet. The type is a record. Okay, you can also have type NS record in this case. Okay, and then your R data. Again, R data is everything that comes after your class type. So here you have different types of entries, different types of resource records in one file. Okay, you can just simply open up a text file, type in all these information, and then you will have your zone file. You will refer to that file using the configuration file for your name server. Okay, this is another type of resource record, which is the start of authority or SOA record. SOA record is usually at the top of your zone file. Okay, as you see, it spans a few lines. It tells you a lot of timing parameters. First of all, you have your, of course, this is your domain, this is your time to live, class in, okay, class type SOA, and then here is this specify the name server that represents or that is authoritative for our apnic.net zone. This next line is the email address, okay. Now this is admin@apnic.net. When we type it in a resource in a zone file, we use dot. Okay, it's the software will be able to handle that. He knows that the domain for that is apnic.net, and then the rest is the email part, okay, the user part of the email address. Now let's look at the other parts, which is the timing parameters. Oh, by the way, first of all, the serial here. Now this is very important. If you remember when I was discussing about primary and secondary servers, I told you that at certain times, the secondary server will ask or will query the primary server, okay, if there are any changes into the zone file. Okay, if there are changes, of course, the secondary servers must pull that information or must pull that zone file from the primary server. Now, how do we know that there have been changes or I made some changes? How? Can anyone tell me? Well, I'm actually pointing at the answer right now. It's through the serial number. Every time you make changes in a particular zone file, make sure that the serial number is updated or incremented. Okay? There are a lot of different ways to write a serial number. As long as you increment it, that's fine. But as a best practice, we usually use the date. Okay? So for example, this one, 2012-11-15. I made changes to my zone file on November 15th in 2012. Okay? So I write it down as 2012-11-15. And the last part, 01, is actually how many times I made changes to that on this particular date. Okay, so let's say I made some mistakes, I need to add a few more things, then I'll increment this to 02. Okay, this is a good practice because we can also know whether, like, it's also a documentation thing. Like, you know when was the last time you made changes. At the same time, you know that you're just incrementing it, okay? And there is no chance that it will, like, your new serial number is different or is lower than the previous one that you used. I have one question from Saji. Can you please let me know the use and meaning of TTL 3600, please? Now, this time to live, 3600 is actually in seconds. Okay, so let's say, for example, if you have a terminal in your machines right now, if you're using maybe a Linux or Unix system or Mac, try to go and use dig. Dig for a particular domain. Let's say dig google.com. Dig is a command, right? Now, when you do that, it will give you a time to live. Now, when you do that again, when you do another dig, that TTL is actually lower than the previous one. Let's say from 3600, it will become 3520 or something like that. That means that it is decreasing. Okay? The TTL is actually, the reason it's called time to live is it's the amount of time that a particular resource record can be saved or can be cached onto a caching server. Okay? After some time, it will expire. So that means that the caching server cannot save it into his cache for a very long time, only until the TTL expires. So when that happens, okay, the caching server will disregard that entry again, and any queries that comes to him, he will now have to do the entire query again from the root going down to the authoritative server. Okay, so that is the use of the time to live. All right, does that answer your question, Saji? I hope it does. So, okay, very good. Thank you for that, Saji. I'll have a look at Tomasi's question after I describe about these other timing parameters. Now here, we have different timing parameters. It's kind of confusing for most people, but let's just make it very easy. The first part is the refresh time. Okay? This is when your secondary servers will ask from a primary server. Okay? So every 12 hours, the secondary servers come to the primary server and ask him, hey, is there any changes? Did you make any updates? If not, then I'll come again after 12 hours. That is refresh time. Okay? Now, if, let's say for example, the secondary server comes to the primary server and he doesn't reply, I will query him again using the retry time. So let's say at 12 midnight, I asked him a question. He did not reply. So I will not wait until the next refresh time, which is at 6 a.m. I will not wait until that, but I will retry again. I will query him again using the retry time. So after 4 hours, at 4 a.m., I will ask him again this question. Now, let's say, for example, your primary server is down, is dead. Okay, it crashed, and he cannot answer the question. The secondary servers will ask him using the retry time up to only the expire time. So after 4 days, I asked him every 4 hours and he did not reply. Then after 4 days, this zone will expire. That means that I will no longer answer any questions or any queries for the domain apnic.net. Okay? Now 2 hours is the negative caching hours. It has to do with time to live as well. Okay? So this 3 is very important. So let's say, for example, you want to immediately, let's say, reflect the changes that you made from your primary to your secondary. Make sure that you have a very low refresh time. However, most of the servers nowadays, if you configure it properly, if you make changes to the primary, you can make it notify the secondary servers. In that case, the secondary servers will not have to wait for the refresh time. It can go right away to the primary server to get the new information. Alright, so does that clear? Any questions with the timing parameters? Now let me go to Tomasi's question. For the serial number, can we use any number that can assist in documentation as you stated? Yes, you can actually make use of any number sequence that you want. Just make sure that they are incrementing. What happens if you say, for example, I just use a random 1, 2, 3, 4, 5 to 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, I use that. After a while, I did not remember what I put. I just put in a random number again. Now, if that new number is lower than the previous one, then the secondary servers will never get the updated zone file. Okay, that is really why we are using a pattern here, which is based on the date. So 2012 for the year, 11 is the month, 15 is the actual day, and then 01 is how many iterations you have done or you've made for this particular zone file for that same day. Okay, so if I were you, I will stick to this. This is the best common practice that everyone uses. Okay, so but yeah, different software, different implementations might have changes. So it's all up to you as an administrator. Okay, so I hope this is very clear, everyone. This is very important if you're a DNS zone admin. Okay, so we'll just go through, we're towards the end of our 1 hour session here. I'll just have a quick rundown of some of the things that you might want to look into, various factors that can affect the function of not just your DNS, like say your DNS system or your DNS software, but can also affect the function of the internet as a whole, right? So DNS performance must be very efficient, okay? It has to efficiently give answers in behalf of the information or the data or the zone file. Now implementing DNS is very easy, as you can see, okay? Most people actually just ignore it because, well, DNS, once you have it running, either you keep it like that for a very long time. It can be a static for years, or it can be quite dynamic. So it depends on the roles that you play. Like if you have a lot of servers that you add into your network every time, then you might need to change your DNS, like update your DNS entries every time. But if you have static network, then it can just stay like that for years. Now, these are the things that you have to look into. Like for your DNS to properly function, okay, it uses very little CPU. However, if you have a lot of domains, you're hosting a lot of domains, maybe you're a hosting provider, then it can also be CPU intensive. If you get a lot of queries for, let's say, a very popular domain name, if you get a lot of queries about that, then it can also affect your the CPU usage for your DNS server. So these are the things that you have to look into. Um, the focus in maintaining the DNS lies in keeping your server up and available at all times. You want your DNS server, it's a critical part of the internet, so you want it to be available 24 by 7. So that's really one thing why we have different, let's say, different DNS servers that is giving the same information. You know what I mean? Like um, you may have, let's say, a primary and a secondary server, but make sure that they are not located in the same network. Okay? Because once your network is down, how can people still reach you? Okay? How will they still have the answers for the DNS? So that's why it's highly recommended that if you have primary and secondary servers, make sure that one is one, let's say, in one physical location, then the other might be halfway across the globe. Okay. You can always have like partnerships with other organizations for them to host your domains or your zones as a secondary. Okay, and you can also do the same for them. Okay, so it is just make sure that you have these types of redundancies. Optimize your DNS type of applications at all times. Okay, if you have many servers, many applications that are available, make sure that you are maybe doing some load sharing. Okay, if you can run multiple DNS servers. Now, depending on how many zones are running, you need to consider when you're reloading the zones, how often do you make updates? Does the DNS server has to load a lot of zones every time? And what is the time, okay? What is the amount of time to reload it? How large are each of your zones? Okay, zone files can be very, very small to a few kilobytes, or it can contain thousands of records. Just take, for example, .com. .com is the most popular, let's say, top level domain. So if you look into the zone entries, although all of them are, or most of them are just, let's say, delegated to others, still there are thousands of these records in the zone file. So it can be very, very huge. Okay, what else? Have to think about zone transfers. Do you have a lot of secondary servers? If so, then that can affect the traffic. It can increase the traffic. It can also affect the performance or the latency of, say, when you have to answer queries. So you may need to look at bandwidth. You may need to have higher capacity. Okay. What else? I think I have one more. Yep, one more here. Are your servers multi-home? That's what I mentioned earlier. That they have to be positioned in strategic locations. They have to be in separate physical locations. How many interfaces are enabled for listening? That means that are you only serving a particular set or a specific set of customers? Now, this has to do with security as well. You don't want your server to be used for any attacks. There have been a lot of cases like that where it has been used because it's open, it's listening to all the interfaces. In your case, if your clients are only your local clients, make sure that you are only allowing DNS queries from that particular interface. Okay, so only the local interface must be enabled. Now, how many queries are you expected to receive? Recursions, dynamic updates. Also, you have to look into those things. Like if you need to make a lot of changes, regular changes, if you're hosting dynamic sites, then these are things that you need to look into. Okay, all of these affect the performance of your DNS server. Therefore, it is important that you allot your resources, let's say your CPU resources, memory resources, okay, and also let's say redundancies for that. Make sure that you have them so that your DNS will function properly and it will serve your domains properly. So that's it. I think that is the end of my presentation. Have any of you, do any of you have any other questions that you wish to ask? While you're thinking about that, I will just type in real quickly the survey. So the survey link is this one. It's also on the slides, but what I'm gonna do is type in the survey on the chat, so it's just easy for you. Just need to click it and it will take you to the SurveyMonkey form. Now this is just very brief, so I encourage everyone to please fill it in. Also, I had a question earlier about the slides and also the recording. Now the slide handouts will be available to everyone as a PDF copy. So if you want to review the materials, okay, if there are parts of the discussion that is not clear to you, then it might be good for you to go over the materials again. Now, if you have questions on that later on, please feel free to send me an email and ask me about it. Now, someone asked me about the recording. For now, I'm sorry to say, but we're not capable of making the recording available to everybody. We are still looking into ways onto how to make this, streamline these things, and then add this probably to our website so we will have access. But for now, we don't have that yet. We will tell you as soon as it is available. All right. So I'm really sorry about that. But yeah, for now, I think it's best to look into the materials, and then if you have questions, send me an email, send me an inquiry about it. All right, so any other questions? Did you guys understand? I hope it has been informative for everyone. DNS is very easy, however, it's very critical as well. So an ample understanding, very good understanding on how it works is essential. Okay, we can't just go on and implement it. Okay, now after this, if you want to know more about reverse DNS delegation, which is the next step that you need to do, okay, you can't only just do forward DNS, which is what we discussed today. You also need some form of reverse DNS delegation. So we will have a look at that in another session. So we will have that at 2:30 p.m. today. So if you're also interested, please feel free to join us. The credentials that you need to access it is the same, so no need, I think it's not necessary for you to re-register again. Just the link should be on our website. Go and follow it and then join us at 2:30. At 12:30 today, we also have another topic which is on routing. So if you're also interested in the networks part, we have a routing basics course that will be introduced at 12:30 today. So that's it for me, I think. I don't see anyone typing in, so I think everyone's settled and everyone don't have any questions yet. Just a brief reminder, if you have any queries also about your resources, please feel free to contact our help desk chat. So that's it for me. Thank you very much, everyone. Thank you for your time and also for your attention. I hope you learned something, and I will see you again in our next e-learning classes soon. Thank you.